Hi, my name is Abner. I'm currently doing. Oh, wait. Hi, my name is Abner. I am doing homework 7, high level synthesis optimizations. I'm doing the last part, which requires us to do different designs and change the pragmas that we see in the code that we have. So, specifically, it wants us to follow the instruction of the homework sheet and set the different pragma combinations. So, we synthesize the design and observe the effects of the pragma in the circuit. I've already done some of the combinations that have been required from the homework, as you can see down here. The original design with no pragmas, and then using array ram, array equals reg, and unroll times equals all, and also as well unroll times equals 0. We're supposed to discuss the results and suggest other pragma combinations that you could insert to generate other types of hardware implementations, and then create a YouTube video showing how the different pragmas are set and explain the results obtained in CW synthesis window. So the first, I've already done most of these, so I'm just going to redo some of them. I believe the last one I did, which I have the node machine open on this side with CWB. The first one I believe I did, scrolled a bit too fast. Let me just go all the way down. Oh, actually I forgot one more. I think the last one I specifically did was original design with no pragmas, but right now I did unroll times equals all, and then the library right equals to reg. So I believe that is design 3. At this point I would be able to save the file, and then I'd go to the analysis options, create the .iff file to analyze as cparse, execute, yes. That creates the main.iff, which is down here, which is this blue folder as well. We're going to resynthesize, which will open up the quality of report file, which is where we get our screenshots for the report. So the first thing to mention is that the ALUT is 0 and the registers are 0. We have a latency index of 1 and clock period of 20 nanoseconds. So I believe it did want us to explain how they're set and explaining the results obtained in the synthesis window. At this point, it sort of just means that everything that we have in our system is being parallelized, since if you come up here, we put unroll all, so instead of being serialized, or otherwise, I believe serialized or in sequential order, it sort of just rolls out the array, meaning that, still going down, let me scroll a little bit up, I am so sorry about that. There we go, damn, having some more trouble. Okay. Here we go. Instead of doing this sequentially, it'll just essentially roll everything out into its own digits, and then once that, it can run everything in the registers, which is why we have a lot of registers, and we just have a single latency, since we're only doing it once, because we unrolled all of them. We could also do partial unroll, but I will do another design that we had here, which I believe was unroll times 0. That one did give us a separate file, because I do believe that all the others had the same output, just because everything was unrolled. So let me save this real quick. Do analysis options. Yep, and again, you just go into the C file, change that. If I wanted to do RAM, then I would just change this to RAM. Just showing how I changed those, but in this case, the one design that I believe was different was this one. So I'm going to do analysis options, analysis settings, analyze C/C++, yes. Main, and then from here we can resynthesize, and I believe I already have the design right here. We're going to see it in a little bit, where we have some critical path delay. Again, we also have AOUTs and some other registers, because we just have them going in sequential order instead of actually being parallelized. So we are going to have some critical path delay. I believe it's the exact same. Let me just go back to make sure that this is the exact code that we needed for the YouTube video. Different packages set and explain the results obtained in CWB synthesis window, and did narrate the video. Thank you. I believe that is everything.